Alright, so welcome back again. My name is Jesse, and in this wonderful and exciting tutorial, we're trying to see how to use machine learning to be able to identify a particular hash, right? The hashing algorithm or the hash type or the hash function of a particular hash test. So hashing is a procedure in which you are trying to use a hashing function or hash function to generate a unique fixed size string of characters, right? Which is very useful. So for example, let's say you have a particular plain text like this. It can be a password, it can be any data. Then you pass it through a hashing algorithm or a hash function. Then it produces a fixed length string of characters, right? Mostly termed as the message digest, right? Or the digest. So this is very useful to secure data and also useful to check for the integrity of a particular file. So if you go to something like Ubuntu, right, and then you download the Ubuntu ISO, they most of the time give you this particular MD5 sums, right? These things are hashes. These things are hashes that are used to check for the integrity of the particular file, to make sure that we compare the file that you have downloaded together with the file here to make sure that it's the same, right? So that's one of the use cases to secure data, right, as in passwords, and also to ensure the integrity of a particular file to make sure that they are the same as you are seeing here. So let's see how to use machine learning to identify the particular hashing algorithm of a hash test. So the default way or the traditional method we use is to use regular expression, right? So you use regular expression. So some of these tools like Hash-Identifier, Hash-ID, name that this hash, height, and hashtag most of the time rely on heuristics and regular expression, because as we said, a hash or hash digest or a message digest, right? That's why it is MD5, right? MD message digest is usually fixed size values or fixed length. So that means that if you know the length of it, you can identify the particular hash type. So let's see an example of these tools. So I'll come back to my workspace here. I'm using Kali. So in case you want to install any of these things, the code is here. You can just go with sudo apt-get install Hash-Identifier to install Hash-Identifier. Hash-ID, name this hash are all Python packages that you can also install. So let's see how to use these three tools. So I'll go back to my workspace. Then I'm going to work with Hash-ID, right? So that dash help. Then you can see how to work with Hash-ID. So this is Hash-ID, it's a Python file. It's used to identify the different types of hashes. So I can just go back to Hash-ID. Then I'll pass in my particular term. So let me pick in a simple term that you want to use. So I have some test here. This is the first test. I want to be able to identify this particular one, the hash type. So I'll come down and I'll paste it here. My paste here, you can consider that's giving us these particular options. So it is either MD2, MD5, or MD4, and these are the top ones. Perfect. So using this approach, Hash-ID, then your particular hash. Let's try the next two, which is Hash-Identifier. So I'm going to split it into vertical, right, so that you can see the other one. So this is going to be Hash-Identifier. So Hash-Identifier is another tool you can also use, and as you can see, it's not looking nice. Let me make it better so that you can see it well. Clear. Let's go with Hash-ID. So it's giving us this particular nice stuff, and then you can pass in your hash type there, right? So let's do the same thing. So I'll go back again, Hash-ID, and I'll paste in my ID. And this one also giving us that is most of them are MD5, as you can see from here. Most of these things possible hashes is MD5. Just as Hash-ID gave us as MD5, MD4, MD5, this is also MD5 with Hash-Identifier. Very nice. Okay, so you have seen two different methods. Now let's see the next method. Just name this hash. So this is going to be name this hash. So nth, that's help. It's also another library that you can also use, right? It goes with the same option. So name that hash, then you specify the test there. Clear. So let's see how to work with it. So name that hash, then I'll go with that's a test, and I'll pass in my test here. So yeah, if I run it, guess that's going to give us our result. So this is also MD5, right? Most like MD5, MD4, NLTP, and domain cache credential, which is almost the same thing that we had here. Very nice, right? As you can see from these are results. So name that hash is also a very nice library. Very cool. So you have seen how to use three different tools, right? Hash-ID, Hash-Identifier, and then name that hash to identify the particular hash type. Now let's see how to use regular expression. So I'll go back again to my workspace. So I'm going to be using pandas. We'll be loading our EDA packages, pandas and NumPy, Seaborn to help us plot it, and then our machine learning libraries. So we'll be using scikit-learn. You can also use TensorFlow. So you're using decision tree, naive Bayes, and logistic regression. Then we are also going to be using it in the format of pipeline. We need count vectorizer or TF-ID to vectorize our test, train test split to split our dataset, and then these metrics to check for the metrics. Okay, so let's see an example. So as we said, a hash is a fixed size or fixed length string of characters, right? So based on what you are seeing from here, this is fixed length, right? It is 32. For MD5 is 32. So, and you can see that this consists of numbers together with values like F and all of these things, right? Alphabet. So using regular expression, you can be able to pick the particular hash type. So let's see an example. I'm going to be using regular expression to make our work easy. Then we move on to use machine learning. So apologies for how long it's going to be. So import array, and then as we said, this is 32 characters, so we'll be using regular expression. So let's go with MD5 pattern, right? So in case you have any question or contribution, you can also put inside the comment section below, which is going to be my array.compile, right? Compile to make it faster in case you are running a lot of tests. Then I'm going to pass in my regular expression. So as we said, it's 32 characters, so it's going to be my 32 characters here. See what I did. 32, right? So it must be 32 characters. Perfect. And then as we are seeing, there's also alphabets and then numbers. So I can just go back again. So anything that is 32, right? But it must consist of alphabet and then numbers. So let's go with alphabet. So alphabet, right? A to F. That is one of the ways. And then capital A to capital D, capital F rather, which is going to be any decade, right? Very nice. So this is very useful. Perfect. So this is one of the ways of trying to identify a particular pattern. So you are just going to be using this regular expression to help us get our test, right? So let me put this entire stuff into a bracket. Perfect. So something like this, right? So any of them is going to work, or without the bracket, it's still going to work. So this is our pattern, right? You can also ignore cases, right? In case you want. So let's check it out in case I want to find this. It's going to be MD. Hopefully it works. MD5. It's going to be array.findAll MD5 pattern. And I'll pass in my example 1. Then now it is able to identify that particular one for us, right? Very cool. If I pass in the example 3, which is more than 32, let's see. Just see that it splitted them into into 2, right? Which is not the best. So that is one of the ways you can also use regular expression, right? Using this particular approach, right? Very, very nice. So sometimes you're supposed to give more rules apart from regular expression to get the actual value. Very cool. So another function we can do is that we can also create a simple function. So by the end of this tutorial, we are not picking all the various algorithms. We are just picking 4 of them, right? You are picking MD5 SHA1, secure hash algorithm 1, the second generation of secure hash algorithm, that is SHA256 and then 512, and then also third generation, but we want to use these ones, 1, 2, 3, 4. So let's build a simple regular expression to help us with that. So I already have my patterns here, so we are just picking those particular values, 32, 64 for SHA256, and then for SHA512 we also have these particular ones here. So the same thing we did here, and I'm going to create a simple function to use this particular way. So this is also another regular expression you can also use, right? But let's go on with this. So let's create the function, right? So I'm going to create a function. I'm going to call it as custom hash ID, right? Or Hash-Identifier. Identifier, right? Something function. Now passing my hash test. The test that I have already hashed. Then I want to use, let's go with this result. So the simplest way is that you can just go with this option. So for algorithm, in my hash, let's use this option, right? So So I'm going to go to my result. This is a simple list comprehension, which in this case, if I'm using a list comprehension, it's going to make our work easy. So I'm going to say that, okay, for my algorithm inside my hash test, right, this particular hash type ID, this hash type regular expression, that's the first thing, right? Algorithm in a particular hash type ID, if that algorithm algo is, let's say that algo, yeah, dot match. Remember that this is the what you are picking, right? This is a regular expression, right? So we can match it, dot match, with my hash test. If that is the case, right, then I want you to pick this like a dictionary. As you can see, this is a dictionary. So I want you to pick this particular regular expression and then return the value, right? So I'm going to go back again and pass it here, then pass in my algo, right? Very simple. So this is a simple way of getting it. So this option here, then now I can return this. So return result. So this is very simple. So now let's try it out. So I have my example one, which was this one. So if I pass it, this is MD5. So since we have for 3, you can add all the various parameters, right? So, but this is for MD5 SHA1, SHA256, and then SHA512, right? So if I come back here and I pass it here, so custom hash identifier, I pass in my example one, and now it has given us that, okay, the possible result is MD5, MD4, MD2, right? If I do the same thing for the other one, so custom hash identifier with example 3, which is more, let's give us SHA, right? Very simple. So that is one of the ways of trying to identify a particular hash type. So you have seen the tools, you have seen how to use our custom regular expression, right, using the simplest basic format in which we created a dictionary of the regular expression, and then we created a function to help us with that. Now let's see how to use machine learning to that. So I'm going to pick my data from here, right, which is the 10,000 or 10 million password list. Then I'm going to be using Hashlib library to encrypt them, right, or to hash them. So our data set here is going to be our data preparation. So data preparation, that the first step, we are going to be using sec list, right? We are just going to pick a password list, right? Then we are using Hashlib library to encrypt them or to hash them. So which this one I've already done, so I don't want to waste time on that. So to save us time, so let me show you a simple example of how to do that. So for example, if I have a test like, let's say H, so say example 1, right? Let's go with example, go with hello, right? And I want to use Hashlib to help us with that. So it's going to be import Hashlib, right? Then I'm just going to go back, let's make it clearer. In case I want to use Hashlib, I can just go with Hashlib.md5, right? Now pass in my string. Let's convert the entire stuff into string. Then let's decode it, right? So encode it to UTF, right? Then if I go back with this option, let's call that my hash test. Now in case I want to get the hash, so hash test dot digest. So if I run it, now it has encrypted the entire stuff here, right? Not encrypted, but it has hashed them, right, with these particular values. Very cool, right? You see that there is a question mark, there is a caret here, right? Very, very cool. So that is how I used to prepare the dataset. So all of these things, dataset here is plain text, right? But I use Hashlib, right, to encrypt them based on the various ones. If I check for the various methods of this, so methods and attributes of the particular library, if I go with Hashlib, it has a lot of hashing algorithms. So if you check it out, you see that we have MD5 message digest 5, we have Blake, we have Blake 2B, we have SHA1, SHA254, 256, 512, the third generation of SHAs, right? You can see all of them. So that's what I use to encrypt our dataset. So I've already done it to save us time, because it seems we are taking a lot of time. So let's load our original dataset. So we're going to load the dataset using pandas. So it's going to be my df pd.read_csv. I'm going to my data folder, and I have my dataset, right? I already hashed them. If I check it out, so we have our dataset here. Apologies for that. So we have this, their label, right, based on the various labels, SHA256, and then the hash test, and then the original weight here, right? So what we're using is that we're picking this, our hash test as our features and our labels as our labels. So let's split our dataset first, or let's first of all check for the class distribution to make sure that our dataset is balanced. Class distribution, this, so df, I go back to my hash test, let's go with my label to make sure that it's equally distributed dot value count. But check it out, the value counts. So all of them are 1,000, right? Yeah, 10,000, right? 10,000 passwords. So that means that it's balanced. We can plot it with cbone sns.count plot. I'll pass in s is going to my label, and then the data is going to be my df. If I plot it out, you're going to see that all of them are the same, right? So SHA256, 512, SHA1, MD5, all of them have the same value. So it is very balanced. Okay, so let's split our dataset. So using printer split, so I'll copy and paste to save us time. Right, so before I copy and paste it, let's get our features and our labels. So we already said that the S features, right, is going to be the hash test, right, which is referring to this particular column, right? Then this is going to be our labels. So that one, we are not doing any test cleaning because we can't do test cleaning for that. I'll pass in my label. Now I can just come back here and I'll pass in my S features and then my Y labels. Then I'll specify the test size to be, say, 0.3, and then let's specify the random state to be 42, right? It can be any number, right? But so it's giving us an error here. So the reason it's giving us this error is because I call it Y label. So Y labels, not Y label. Yeah. Okay, perfect. Now we have gotten our dataset split. So let's build our pipeline for the model. So the pipeline is going to consist of two aspects. It's going to consist of the data to data stage, data to data, and then the data to model, which is usually the machine learning algorithm, right? So I'll call it as my pipe LR. Let's first build the first one. So decision tree. We are using decision tree. We can use naive Bayes, right? But naive Bayes build with independent, like mostly rely upon building features independently, right? So they are not dependent on that. So let's use decision tree and then logistic regression because it is mostly characters. So I'm just going to go back with my pipeline, and I'm going to pass in the steps for that particular pipeline. So we are going to have our transformer, which is going to be our count vectorizer. So CV count vectorizer. We can use TF-ID in case you want. You can even specify that the count vectorizer should use characters instead of the normal default one, right? Anyhow you want it to be. That's going to be the first one. Then the next one is going to be our model. So decision tree, DT for decision tree, then decision tree classifier. That's going to be our first pipeline, right? So let's do the same thing for logistic regression and then naive Bayes. So this is going to be for logistic regression, to LR for logistic regression, and then this is going to be for naive Bayes. Right? So let's change this one. From this one, I'm going to call it as my logistic regression model, and and then this is going to be for my naive Bayes classifier, right? So naive Bayes is going to go with multinomial. So let's call this one as naive Bayes. Perfect. So you have built 3 different pipelines. Perfect. Now let's train. Fit on data to train. So I'm going to work with the first one. We are going to be working with the decision tree and the naive Bayes to see the difference. So let's go with the decision tree. Right. So it's going to be my pipe dt dot. So most of the time is you can also use a dummy classifier to check for the base of it. So let's use a dummy classifier. So pipe d dummy, right? Then let's do the same thing to get the base model. So this is going to be for the dummy classifier, so I have to import it from dummy. So this is going to be base model, right? So from sklen dot dummy, import dummy classifier. Perfect. And then we are using dummy classifier to help us with that. So dummy, and let's call it as dummy, right? So we have the dummy classifier, so that is going to be our base model. Most of the time the dummy classifier, since it's a base model, right, it doesn't learn anything. It memorizes but it doesn't learn. So base model, so pipe dummy dot fit. I'm going to pass in my s train and my y train. So let's check it out, and then from there we are going to build get accuracy. So that was very fast, right? So let's check it out. Pipe dummy dot score. Now passing my s test and y test. So this is going to be the base accuracy. Very, very low, right? 0.24, 24%, right? That means that is the base one. So anything above this is going to be good, right? So let's build a first model using decision tree. Anything that is above this is good, right? So I'll just pass in the same thing to score, no score, but fit on the data set. So s train and then y train. Let's check for the time. I want to check for the time it took. Hopefully it doesn't slow down my system. So time 8. So sometimes I don't know what I've noticed. Sometimes when you use the time it macro, it may slow down the actual time. I don't know. So it's taking some time for it to run. Then whilst it's running, let's do the same thing for the rest, right? So I'm going to copy this one here and repeat it for the other model. So I'll copy this. This is going to be for loss regression. And let's do the other one for naive Bayes. Naive Bayes, right? So this is going to be my NB. So let's see whether that's finished. It's still running. So after that, you're going to check for the accuracy of this. It's going to be my pipe dt.score. I pass in my s test and my y test, right? So this is going to help us get the accuracy. We can also use another approach for the accuracy, in which we just go with our y predict, and I just go with my pipe dt.predict. I pass in my s test, right? Then we can use the accuracy function. So in case you have any question or contribution, you can also put inside the comment section below, and then you can also check our links below for some more materials. And we also have a Patreon channel, so in case you also want to help us, you can also sponsor the channel. Okay, take some time. Okay, it took some time, about 44 seconds, right? It took like forever. And then let's see the accuracy of this particular model. Wow, that is 40%. Wow, not that bad, right? 40 is not that bad, right? I think the one I did it earlier, it was better. Okay, so that is very cool, 40%. So we can also check for the classification report for this particular one. So let's try that one out. Then in case I want to check for the classification report for this particular model to see how accurate it is. So just give it the classification report. Can't spell classification report. Then you work on the other one. So print. I don't know whether anybody would fancy regression reports. So I'll just go with my Y test, right? Yeah, sometimes this one I always sometimes make a mistake with this. The true and then the prediction. Okay, perfect. So based on this, you can see that let's take the F1 score. They are not that bad, right? They are almost, the higher the better. So SHA-51 is very high, right? It's very good in predicting SHA-51, then followed by the rest, right? And the accuracy of the model is this, which is not that bad. But based on our base model, which we had, which was 24, right? Our decision tree classifier is telling us that it is 40. That is twice, almost twice of it, right? Very good. So let's try with the other one. So I'll take off this because it took a lot of time. And then we will work on the rest. So in case I want to make a prediction, so while this one runs, I'll run these ones, right? I don't want to just take the time. You can do that later. So whilst it's running, I want to use this particular mode that you have built to make some prediction. So I'll just get the accuracy for this one. So pipe allow.score to just get the accuracies. I don't know how my English is, but I hope it's beneficial. Some people have been complaining about my English. My apologies. It's going to be S test and Y test. Right, you want to check for the accuracies of these particular models. So after that, we will move on and then we will make some predictions. In case I want to make predictions, it has finished. Wow, it's finished faster, right? See how it's finished faster. So let's check it out. This was wow. Wow, the logic regression gave us 70. Wow, that is interesting. I was initially thinking the decision tree would have given us something better, but let's check for the F1 score for these ones and see. Initially I was thinking the decision tree would give us better accuracy, but anyway, so let's go back again. Let's check for the F1 score for this one. So this, so print, then let's do the same thing there. So almost the same, right? Not that bad. So let's move on from here, right? See, that's why I give it the same thing. It's supposed to be LR, not DT. Okay, so okay, the higher the better, so it's good. The model is good. Let's try for naive base. I'm sure naive base will finish very fast. As I said, see that has already finished. Naive base is very good when it comes to test classification, but sometimes it fails. You see that this is 25. Right? That means that of the three models, the best is logic regression, followed by decision tree, and then the naive base, right? So let's make a single prediction using this particular one. So I'm going to call it print. I'm going to pass in the particular model. So this is going to be decision tree, right? And I'm going to pass in the result. So pipe decision tree dot predict to pass in the result. So we already have our example here, which was example 1. And as we know, this is MD5. So we want to see whether our model will be able to predict as MD5. So I'll repeat the same thing for the rest. So let's check it out. Okay, so all the models were able to predict that it is MD5. As you know, this is MD5, but the base told us that it's SHA-512, which is not the correct one. Let's try an example. So I'll be trying example number 3. Let's try the other one, right? You already have some other ones that you want to try. So let's try this one, 3. So this is SHA-56. So this is what you're trying to try. It says SHA512. I'm not sure, but let's check if the model will give us the correct prediction. So I'll copy this and make another prediction. So this is going to be example 3. 3, 3, 3. So let's see. I don't know, all of them were the same thing. I'm surprised this one was wow, all of them is MD5 too. Interesting. So our model predicted these ones as MD5, but let's see the accuracy, right, of this one, the probability, prediction probability of these ones. So I'll face that one out. So when I run it back, you could see the probability for all of them, right? So for the decision tree, this was very high. Amazing. Some of them are high, some of them are low. So you have seen how to build a simple model. Let's say this particular model. So I'll just use JobLib to save the model. Then maybe use it to build an app using the two of them, right? So this is how to save it. So I'm saving this. Today's 1st. So 1st December. In case you're watching from the future. Right. Perfect. So I'm going to save the decision tree, and I also save the loss regression. So let's call it as DT, and then this is going to be 1st December, right? Then I'm going to pass it here, so DT. Okay, perfect. So you have seen how to use machine learning to be able to detect the particular hash type. It was not that very good, but we were able to see the approach, right? So we can just combine the regular expression together with the machine learning model to be able to make it more performant. And all of them depends on the data. Based on what we had, the amount of data set that we had was just 10,000, right? But we can make it better, and we can also change the vectorizer from count vectorizer to maybe TF-ID, or change it from words to characters, right? So that is another thing you can also do. So thank you for watching this exciting tutorial. You have seen how to use several tools: hash ID, regular expression, machine learning, to be able to identify the particular hash type. To see the next session, stay blessed.